I'm going to show how to use the latest version of SynthMaker hosted inside the GarageBand on macOS. So if you start with an empty project, choose the software instrument. This is playing this classic electric piano, but you can go to your plugins and you can change it to VI Desk SM instrument. And now you're playing the sine synth inside the SynthMaker. This is the same as in the standalone version, but as you notice, as a plugin you don't have the input MIDI and output audio because this is a plugin, so it's plugged already. So you can go inside, same as in the standalone version, and I'm going to create some notes. So this would be playing like live, but you can create MIDI region, and then you can create some notes. Let's see, create notes, and I'm going to move this there, and we want it to loop. So this is playing, it was I think 5 bars. Let's do just 1 bar, and let's see what this does. Okay, we don't want a metronome. Okay, so this is your SynthMaker plugin playing 1 note. Let's put maybe another note somewhere, like there. Okay, back to the plugin. Now, for example, we could show the labels of our ADSR, and let's have a knob to control the attack, for example. I'm going to make it a very short attack. So a long attack would be like this. This is 1 second, not even that long, but back to short. And now I'm going to increase the release. So the note stays playing a little after release. And that's basically it. The rest would be like in the standalone version. You would be able to bring in like an oscillator, etc. Let's see, or car plus instead of your sine. So here I think car plus takes frequency, so frequency from there, and now instead of our sine, let's see what this does. Okay, so I'm going to stop it. One thing you have here, you also have in standalone version, but it's not fully plugged, is transport information, and they tend to be doubles because you need a precision. Like for example, you have your beat position, and when you're playing, you'll see the number corresponding to the beat that's playing in your transport. So you see this goes from 0 to 4 cycles around. It doesn't, when 4 becomes 0. You also have sample position. Again, this is a double. Also note that you can see the connectors don't have the dots around. So this is not a 16 voice. Bit position is just 1 for all the voices. Same with sample position. So I'm going to show here the sample position. You see it's similar to the bit position, except it's in samples rather than in bits. this needs to have this double precision rather than just being a single float, because if you keep playing, like in this case it would be fine because we're just playing one bar, but if you keep going, at some point you would lose sample precision, because a single float you would have 6 digits, and when it needs more than that it starts losing precision. So things you could do with this bit position, there will be components coming like sequencers and stuff that you'll be able to plug to them to control, but you'd also be able to manipulate your beat so that you can slow it down or make it go faster. For example, we could here multiply by let's say 0.25, so it would go 4 times slower. 0.25. So now instead of going from 0 to 4, it would go from 0 to 1 and then cycle around. You have a way of seeing this at the moment, even though there will be sequencing components coming. That will be a lot more useful, but there's this ZTO rotator that was used for the Euclidean, to create Euclidean rhythms. Let's see the labels. So there's a ZTO there, which means ZTO means 0 to 1. So this goes around depending on the number that goes there, where 0.5 would have it going like half the way around. So we need to convert our bit position to we don't have this kind of float there, so I need to create that component, but we can convert it to a single precision. And then this one has it, no, wrong one. Now this one has C float, has a C float to an E float. So here we're dealing with 3 types of data. As you can see, like this is double precision, which I explained why you need it. This would go to single precision float. Normally we wouldn't need this, we just need to have a component that goes from double to an E float. So an E float is like an event. It only happens when it changes, while the other ones, they run, they're constantly running. So now when we play this, you can see that our ZTO rotator goes around once for every 4 beats. So like for a bar, we could make it go twice as slow, and now it would go around every 8 beats. But because we're only playing a bar, when it gets 4, it goes back to the beginning. And if we were at the original speed, it would go around 4 times. So that's, I think for now that's it. I hope to soon have normal sequencing components, so you can take advantage of these transport. There's also transport tempo. Transport tempo here. Let's show it. Transport tempo is now 120. So let's like change it. When you change it there, you'll have it here. So these 3 are quite important for you to do like very custom stuff, very flexible, controlling your sequencers and make synthesizers from very low level, the same way you would do with coding, except here you don't need to know how to code.